We will now elaborate on the role symbols have in Lisp programming. A symbol in Lisp is unique in a namespace called package in Common Lisp. Symbols can be tested for equality with the function EQ. Lisp programs can generate new symbols at runtime. When Lisp reads data that contains textual represented symbols, existing symbols are referenced. If a symbol is unknown, the Lisp reader creates a new symbol. In Common Lisp, symbols have the following attributes: a name, a value, a function, a list of properties, and a package. In Common Lisp, symbols can use characters including whitespace and new lines. Symbols also can be used as identifiers for any kind of name programming constructs like variables, functions, macros, classes, types, go-to tags, and more. Symbols, think of them as words in a dictionary, not as strings. They are similar to strings, but different. Symbols live in packages, however, strings do not. Now we take a closer look at equality in Lisp. Internally, Lisp refers to objects via pointers. The fundamental equality operation is EQ. Built-in functions and special forms in Lisp. We will now take a broader look on built-in functions and special forms. Depicted below with examples, they are setQ. This function assigns values and associates a list with a list name. Example shown below. The quote function. This function prints list item or items, as shown in example below. The CAR function takes the first element of the list. The CDR function removes the first element of the list. Examples shown below. The append function merges list. Next, we have the listP function. This function tests an argument to see if it is a list, as shown in the example below. The eval function evaluates an expression. The cons function adds a new first element to a list, as shown below in the example. The expt function calculates powers. The xqrt function calculates the square root. The max function finds the largest number in a sequence. The min function finds the smallest number in a sequence. Defining functions. This is a feature of Lisp programming that allows functions to be defined by the user, where the defun keyword can be used to define new functions. As shown in the examples below, defun square x function calculates the square root of the value x. The defun message function prints the message hello. The defun times 3 x function multiplies the value of x by 3. Argument lists and keywords. Lisp's notation for argument lists of functions is a subset of the common Lisp notation, as well as the familiar and optional and rest markers. Common Lisp allows you to specify default values for optional arguments, and it provides the additional markers and key and aux. This is depicted below by examples. What is Lisp good for? Ideas and experimental programs. The algorithmic ideas which Lisp inspires are often powerful and elegant. Even if Lisp is not the target programming language, thinking about how to tackle a programming job using Lisp can pay worthwhile dividends in ideas for data structures, for the use of recursion, and for functional programming approaches. The use of Algol-like languages, or Fortran, tend to limit a programmer's imagination, and both applications programmers and systems programmers can benefit by remembering Lisp. Lisp is useful for building and trying out programs to solve predominantly non-numeric problems such as natural language parsing or dialogue processing, symbolic formula manipulation, retrieval in a Lisp encoded database, backtrack searching, example game playing, and pattern recognition programs. What is artificial intelligence? AI for short. Artificial intelligence is the intelligence of machines and the branch of computer science that aims to create it. AI is defined as the study and design of intelligent agents, where an intelligent agent is a system that perceives its environment and takes actions that maximize its chances of success. John McCarthy, the inventor of Lisp, defines it as the science and engineering of making intelligent machines. The field of artificial intelligence was founded on the claim that a central property of humans, that is, intelligence, the sapience of Homo sapiens, can be so precisely described that it can be simulated by a machine. This raises philosophical issues about the nature of the mind and the ethics of creating artificial beings, issues which have been addressed by myth, fiction, and philosophy since antiquity. Artificial intelligence has been the subject of optimism, but has also suffered setbacks, and today it has become an essential part of the technology industry, providing the heavy lifting for many of the most difficult problems in computer science. AI research is highly technical and specialized, and deeply divided into subfields that often fail to communicate with each other. Subfields have grown up around particular institutions, the work of individual researchers, the solution of specific problems, long-standing differences of opinion about how AI should be done, and the application of widely differing tools. The central problems of AI include such traits as reasoning, knowledge, planning, learning, communication, perception, and the ability to move and manipulate objects. General intelligence or strong AI is still among the field's long-term goals. We now take a closer look at some famous AI applications written in Lisp. Maxima, as the first large computer algebra system. ACL2, as a widely used theorem prover, for example used by AMD. Spike, the planning and scheduling application for the Hubble Space Telescope, also used by several other large telescopes. Dart, as a logistics planner used during the First Gulf War by the US military. This Lisp application alone is said to have paid back for all US investments in artificial intelligence research at that time. Metal, one of the first commercially used natural language translation systems. American Express Authorizes Assistant. This application checks credit cards transactions. CYC, one of the largest software systems written. Representation and reasoning in the domain of human common sense knowledge. We discussed the famous applications that use Lisp as their basic programming language tool. And here we take a look at the reasons why. The typical artificial intelligence areas for computing with symbols are computer algebra, theorem proving, planning systems, diagnosis, rewrite systems, knowledge representation and reasoning, logic languages, machine translation, and expert systems. Why use Lisp for artificial intelligence? Most ideas and experiments involving Lisp includes artificial intelligence and helps us understand the nature of our own intelligence in terms of vision, the ability to make sense of what we see; in terms of natural language, the ability to communicate with others in English or other natural languages; in terms of planning, the ability to decide on a good sequence of actions to achieve your goals; in terms of robotics, the ability to move and act in the world, possibly responding to new perceptions; and experimental programs that Lisp are used for include the fields of medical diagnosis, equipment repair, computer configuration, and financial planning. Lisp is an excellent prototyping tool. It also supports symbolic programming very well, and Lisp is very powerful.